hot this summer, but do you know what's even hotter? The complete 1-year program by CBSE class for mathematics from grades 3 to 10. 100% only IIT and IIT teachers. This course completes Vedic mathematics and competitive exams like Olympiads and Math Kangaroo. The classes are starting from 5th of May 2025 and all of this for 9,999. Is the price a bit high? Don't worry parents, the mega offer from CBSE class this summer season is live. And in this mega offer, you can get this complete 1-year mathematics program only for 999, which is even lesser than 2 rupees per class. Parents, what do you get these days for 2 rupees? Not even a good cup of tea. But here at CBSE class, you are getting quality classes from IIT and IIT teachers at even lesser than 2 rupees per class. Parents, hurry up, quickly click on the link given in the description below or scan this QR code to complete the payment and book your seat.
Start. Alright, dear students, welcome back to yet another session from CBSE class in this Ultimate Bridge series, which we have started, or which we started a long time. There have been many videos, but this series we have started to help students that are moving from grade 9 to grade 10 to let you know that grade 10 is not at all difficult, provided your grade 9 concepts are super solid. Alright, in this series we have covered many videos, so make sure to check out our channel. And just a reminder, we have started this series in 3 different languages. Right, so if you want to learn in Hindi, you can watch Shrikesh Sir class, who's from IIT Gandhinagar. And suppose if you want to watch the session in Telugu language, you can tune into Kaushik Sir class as well. All right, in this session, what we're going to cover is circles. Now, circles is not a new topic to you. In grade 9, also, you had a chapter circles. In grade 10, also, we have a circles. And the best part is all the concepts that we studied in grade 9 will be used in grade 10 as well. All right, so if you don't know me, dear students, let me just introduce. My name is Rishab. I'm maths master teacher here at CBSE class, and I have completed my education from IIT Jodhpur, and I've been doing this for quite some time now. All right, so let's start, dear students. So just a further reminder that Maths 1-year program is up and running. It will start from May 5th. The enrollments are in progress, and the special discount which we have offered is if you are enrolling right now, you will be getting this in only rupees 999. So make sure you can either scan the code, this QR code in front of your screen, pause the video, scan it, and quickly complete your enrollment. Or if you're having trouble scanning, just check out the link that is provided in the description box below. I want all of you to attend this program. This is especially very useful for students that are in 10th grade. This is your board year, right? So if you're in board year, this is going to be very important program for you. It is for 1 complete year and price is same whether you're in grade 3, 4, 5. So if you have any, if you know any person who wants to study maths, having problem in maths, this program is taken care by all IIT and NIT teachers, right? Okay. Then let's start. So in grade 9, we studied circles. You remember what they studied? Arc subtended by a chord and an arc, angle subtended by a chord and an arc, perpendicular from the center to a chord. We studied cyclic quadrilaterals as well. In grade 10, what we're going to study tangent to a circle, number of tangents from a point to the circle, area of sector, and area of segment. All right, so let's start. In today's class, we'll start with what are tangents, number of tangents from a point to a circle, the area of sector of a circle, and area of segment, which is very important. So make sure you stay till the end. All right, this is the very favorite topic, and the maximum number of questions come from this topic. It is very, very, very important, and the questions are very easy. Like if you understand the concepts, I'll make sure you will never do a question wrong. Right? All right, let's start. So first of all, just do one activity. Pause this video right now. What you have to do? Just take a sheet of paper and take a circle and a line. You are only allowed to take one circle and one line. Now, what are the possible number of cases that you can get? All right, let's go one by one. First case is that you will get a circle and a line which are not intersecting. For example, this case, or maybe like this or like this. But the thing is, first case is that the circle and line are not at all touching, right? So we call it as non-intersecting. Right? Another case is like circle is intersecting the line, or a better thing to say, the line is intersecting the circle at 2 points. Now, here's a question for you. What do you think? Can a line intersect at a circle at more than 2 points? No, right? So this special line which intersects the circle at 2 points is known as a secant, right? Okay, great. The third case is also possible if you pay attention. The third case is that line and circle just touches at 1 point, right? At this case, for what is the case? When the line just touches the circle at one point and one point only, we call that as a tangent. Clear? I hope it is clear. So, what is the definition of a tangent? We can say if we connect it to, let's say, secant, the tangent to a circle is a special case of secant when the two endpoints of its corresponding chord coincide. So, don't worry about this. All you have to remember is that tangent is a line which touches the circle at one and one point only. Cool? Clear? Great. All right. So the common point of the tangent and the circle is called the point of contact. So as I told you, only one point will be there, and this point, let's say if I'm naming this point as P, this is called as point of contact. Right, and the tangent is said to touch the circle at the common point. Of course, yes. So the common point is the point where the tangent touches the circle, and we call that as a point of contact. Clear? Right. Now, there are some theorems, and actually, when not you don't have much theorems as you had in grade 9, but application of these theorems is very much required. So, what is the first theorem? First theorem says the tangent at any point of circle is perpendicular to the radius through the point of contact. That means, suppose if I have a circle like this, let's name this center as O, and I have a tangent like this, right? Now, the tangent at any point of circle is perpendicular to the radius through point of contact. That what it means to say that if this point of contact is P, this angle is 90 degree, right? Now, there are many ways to prove this theorem. First of all, did you understand this theorem or not? How will we say that if I draw a, let's say a line segment to a tangent at the point of contact, that will be perpendicular, nothing other than that. But this is very important theorem, five-star theorem, and you know what to do with five-star theorems. You have to write it down and memorize it by heart, right? If you have to prove this theorem, actually the proof is very simple, not required. The thing is, suppose if we have this point and we have this point, right? Now see, this is radius, right? If I consider this line, this is not radius, right? Because this is R, let's say this is some D. So this is not radius. So if we draw one like point like this is R and this is D. So what we can say that all the lines that we are drawing from center of the circle to the tangent other than point of contact is more than R. So what is the shortest line? Of course, this is the radius. So that's why it is 90 degree. Why? Because the shortest length is a perpendicular line. Clear? But remember the theorem. The proof is not at all important. The theorem is the tangent at any point of a circle is perpendicular to the radius through the point of contact. Right. Now, through this theorem, we can also conclude that at any point of a circle, there can be only one and one tangent. Again, very important theorem. Write it down. By this theorem, it is a conclusion that at any point on a circle, there can only be one and only one tangent. This type of questions, this type of knowledge is very important, provided you are getting some MCQ questions, right? So, in order to score full marks there, remember these small points as well. Right. One more remark is there. The line containing the radius to the point of contact is also called normal. What does it mean? That suppose if I have a circle, this doesn't look like a circle, but okay. So if this is a tangent, this line which is perpendicular is sometimes referred as normal. Okay. So just another information for your sake. All right. Okay. Next. Now suppose if we have to find the number of tangents from a point on a circle. So case one, point is inside. Now suppose if this is center O and this point is, let's say, point T. If the point T is lying inside the circle, what do you think? How many tangents can we draw? None, right? Because if the point is inside, it will intersect the circle anyhow, right? So when the point is outside, the number of possible tangents are zero. Clear? Now, case two, if there is one and only one tangent to a circle passing through a point lying on the circle, that is, if I take a point, let's say this is point T, and this time point T is lying on the circle, then there can be only one and only one tangent. It makes sense, right? If the point is lying on the circle, on the circumference of the circle, there can be only one tangent. Clear? And case three is, suppose if the point is lying outside the circle, then we have two tangents to a circle through a point of contact lying outside the circle. That is, two tangents are possible. This is tangent number one and this is tangent number two. Again, very easy point. I hope it is clear. Right. Now, the major thing is the length of the segment of tangent from the external point and the point of contact within the circle is called length of tangent. That means if I have a circle like this, and suppose if I have extra point T, then this length is called as length of tangent. Now you must be thinking, sir, why both are called length of tangent? Are the both lengths equal? We will get to know. All right. And the thing is, what you thought of this is correct. The length of tangents drawn from an external point to a circle are equal. That is, if I have a circle and if I have, let's say, this is point T and it is intersecting at, let's say, point P and Q, or P and Q, then TP is equals to PQ. That is, length of both the tangent has to be equal. Now, how can we prove this? In order to study proof, we will discuss in our LTC program, but I'll just give you one hint. So what we can do, we can just see O, this is perpendicular. This is perpendicular, right? What I will do, I will draw this line. Now, in this triangle POT, this is R, right? This is 90 degree, and see this is a common tangent, right? Then by RHS congruency, I can prove that PT is equals to PQ. The proof of it, we will be covering in our master's program. So if you're interested for this, complete your enrollment right now. Just for 999 rupees, we will be covering all the theorems, everything that is important in detail. Great. All right. Now, there's one remark here as well. The center of the circle lies on the bisector of the angle between the two tangents. What does it mean? That if we have this, and this is T point, and if I'm drawing tangents like this and like this, then this is O, then this is actually an angle bisector. That means this angle is equals to this angle. Clear? Very easy. Nothing new here. All right, great. Now, let's do one question. The question is, prove that in two concentric circles, the chord of the larger circle, while touches the smaller circle, is bisected at the point of contact. Now, how will we do? If I have to draw the diagram, okay, I will draw the diagram here. So two concentric circles, what does it mean? Like we have a circle here and we have a circle here. Concentric means both are sharing the same center. Let me name this as O. Okay. Now chord of the larger circle which touches the smaller circle. That means we are talking about this chord, right? And it is touching somewhere here. Let's say this point as, okay, T. What we have to say, it is touching the smaller circle, that is, it is a tangent to that point. It's bisected at the point of tangent. So if we name this as P and Q, so we have to prove that PT is equals to PQ. Now, how we can prove this? Okay, first is I will join this OP and OQ like this. Right now, if I join OT as well, can I say this angle is 90 degree? Of course, yes. Why? Because we just learned the theorem that the line which I'm dropping from the center to the tangent is 90 degree. Okay. Now see the triangle POT and triangle QOT. Okay. If we see this triangle, see this is R radius of the bigger circle, correct? So I can see OP is equals to OK. Yes, of course. OT is equals to OT. Both are common. And angle OTP is equals to angle OTQ is equals to 90 degree. So what do we have here? That two sides are equal, hypotenuse is equal, and the angle is 90 degrees. So what I can say from this, I can say by RHS congruency, both the triangles are congruent, and if both the triangles are congruent, I can easily write that by RHS congruency, PT is equals to QT. And that's what we have to prove, right? That the lines are that the chord is bisected at that point. Clear? See, all this using theorem 1 and some congruency rules which you have studied in grade 9 only, we are able to prove this. Great. All right. Let's do one more question. The question is, two tangents TP and TQ are drawn to a circle with center O from an external point T. We have to prove that angle PTQ is equals to twice of angle of PQ. Now, first thing, if you have a word problem, what I will do, I will draw a diagram. So what is it? Two tangents TP and TQ. That means T is outside point. This is center O. Okay. So this is TP. This is PQ. Okay. Prove that PTQ is twice of OPQ. So first of all, what is it asking? PTQ. That means it is talking about this angle. So I will first complete the figure. Okay. So PTQ. PTQ. So this angle, let me name this angle as X is equal to twice of angle OPQ. OPQ angle is this Y. Right. Okay. So we have to prove that PTQ, that is X, is equals to 2Y. Now, how to prove this? First of all, do you agree with me that angle OPT is 90 degree? OPT is 90 degree. Why? Theorem, right? This is PT is a tangent. I'm dropping one line from center to that point that will be perpendicular. If this is Y, can I say this is 90 minus Y? Of course, yes. Why? What I'm saying, angle OPQ is equals to Y. And since angle OPT is 90 degree, I will write QPT angle is 90 minus Y. Clear? Now, if this is Y, that means this is an isosceles triangle. Why? Because OP and OQ are equal, both are radius. That means this angle will also be Y. So what will be this angle? Again, 90 minus Y. So I can also write that angle PQT is equals to 90 minus Y. Correct. Now, if we see this triangle, if I draw this triangle separately here, this angle is X, this angle is 90 minus Y, and this angle is again 90 minus Y. Now, what is the angle sum property of triangle? All the three angles should be equals to 180 degree. That means X plus 90 minus Y plus 90 minus Y is equals to what? 180 degree. If I try to simplify this, what I will get? This implies X plus 90 is 180. 180 degree minus Y minus 2Y is equals to 180 degree. Now 180 will get cancelled. What will I get from here? X is equals to twice of angle Y. Isn't that what we have to prove? Of course, yes, X is equals to 2Y. So we have proved X equals to 2Y by just the properties, but the theorems that we have learned up till now. Clear? I hope it is clear. Very easy. Great. All right. Now, what is a sector of a circle? Now, sector, have you ever had a pizza? Right. So suppose if this is a pizza and I'm taking one slice, that is nothing but a sector. So just let's read the definition. The portion or part of the circular region enclosed by two radius, that is R, and the corresponding arc. Now, arc you know, right, in ninth grade. This APB is arc. So this portion is called as sector. Now, sector can be two. One is minor sector, one is major sector. What is minor sector? The sector that is smaller. Minor means small, right? So minor sector and the other part other than minor sector will become major sector. Clear? All right. So in this thing, what we will say, OAPB. OAPB is the minor sector and OAQB is the major sector of the circle with center O. I hope it is clear. All right, great. So if this is sector, now just tell me one thing. If this sector is, let's say X angle, if this angle of minor sector is angle AOB is X, can I say this angle is nothing but 360 minus X? Right? Of course. So angle AOB is the angle of the minor sector, whereas 360 minus angle AOB is the angle of the major sector. Clear? Great. So X and 360 minus X. Right? Now, what is segment? Segment, as you know, segment, you understand the English word, right? Segment is the portion or part of the circular region enclosed between a chord and the corresponding arc is called segment. That is, if I draw A and B is one chord, then this part, this part is called as segment. Of course, this is minor segment. Again, same thing. Minor means smaller, so this is minor segment. And other than that minor segment, this is major segment. I hope it is clear. So minor segment is clear, major segment is clear. Correct. So what do we have? We have sector, area of sector we have found. Area of sector, I'll tell you actually. Sector, you know, minor sector, major sector. Segment, now I also know what is minor sector, minor segment and major segment. Clear. So in this case, if we can see APB is the minor segment, whereas AQB is the major. This is segment, not sector. This is segment of the circle. Clear? Great. All right. So just a remark, when we write segment and sector, normally we will mean minor segment and minor sector. Otherwise, stated otherwise means whenever in all such cases, if we are just seeing segment or sector, we will always consider this as minor sector or minor segment. Clear? All right. Now, how to calculate the area of the sector? So first of all, if we are finding area of sector, that means what we have to find area of minor sector. That is sector OAPB, right? It is given by theta by 360 into pi r square. Now the major thing is that theta here has to be in degrees. Do you know what is the relation between degrees and radians? That is 2 pi radians is equals to 180 degrees. right? So 1 degree will be equals to pi by 90. So always make sure you remember this. Okay, this is not 2 pi, this is pi equals to 180 degree. That means pi is 1 degree is pi by 180 degree, right? Just remember this relation. This is very, very, very important relation. So theta, but in your all cases, theta will be given in degrees only. So you don't have to worry about that. Area of sector of angle theta is equal to theta by 360 into pi r square. This is minor sector, right? Now, just, if you have to find, let's say, length of an arc of a sector of angle theta, length of arc, you already know how to find theta by 360 into 2 pi r. Again, theta has to be in degrees. So theta, this is angle theta over 360 into 2 pi r, that will give us the arc length, that is A, B, and B. I hope it is clear. Great. All right. Now, what is it? If you have to find, let's say, area of segment, that is, we have to find this area of segment. How will we do? Can I calculate area of sector OAPB? Of course, yes, that is given by theta by 360 into pi r square. Can I calculate area of triangle AOB? Yes. If by using all the formulas, I can calculate area of triangle AOB also. So if I subtract the bigger that is the sector area minus the triangle, which will it give us the area of segment? Of course, yes. So it will be given by theta by 360 into pi r square minus area of triangle OAB. Now, in many cases, the triangle area is already given. In many cases, you have to find it manually. Clear? I hope it is making much sense now. All right, great. Okay, now there are some remark, and this is very important. If we have found, let's say, area of sector, and always when I'm saying sector or segment, I am meaning major segment or minor segment. So how will I find area of major sector? So suppose if you have found area of, let's say, sector OAPB, this is, let's say, let me name this as X. And if I have to find the area of the major sector, what I will do, I will just subtract the area. So pi r square is the area of complete circle. I will just subtract area, that is X. That is written. Area of major sector equals to pi r square minus area of the minor sector. That is major sector. That is complete circle minus minor sector. Similarly for segment, if I know this area, let's name this as Y, then the area of the major segment will be given by pi r square minus Y. That is written here, that area of major segment AQB will be given by pi r square minus area of the minor segment AEB. I hope it is clear. Great. Okay, let's understand this through a help of an example. Suppose we have to find the area of sector of a circle with radius 4 centimeter and angle is 30 degree. We have to find the area of sector. So first thing first, how will I find the area of sector? I know the formula, theta by 360 into pi r square. What is A? What is A? See, always remember, don't forget this formula. You're seeing this, right? Area of sector. Don't forget this formula. Okay. So if I found area, what is theta? Theta is 30 degree. I will write 30 over 360. Pi is given. I will leave in pi only. Pi into radius is given 4. So 4 square is 16. I can find this. This is 1. This is 12. Yes. So what I will get? 16 pi by 12. I can also simplify this further. 2 8s are 16 and 2 6 are 12. Again, it goes by 2. 2 4s are 8 and 2 3s are 6. So what answer I'm going to get? 4 pi by 3 units square or square units. Okay. Now we have found the area of sector, but is it minor sector or major sector? So minor sector area is, if it is not mentioned, it is minor sector. So what is the area of minor sector? It is 4 pi by 3. Right. Now I have to find major sector area. How will I do? I will subtract pi r square minus 4 pi by 3. Right. Area of the circle minus area of minor sector. What is r here? R is 4 centimeter. That is pi into 4 square is 16 minus 4 pi by 3. Can I take LCM? Of course. If I take 3 as the LCM, I will get 48 pi minus 4 pi. What I will get? 44 pi by 3. So this is the area of major sector and this is the area of minor sector. If I add them, I will get the area of complete circle. I hope it is clear. It is making sense. Right? Is it difficult? Of course not. Very easy topic. Right. So once again, dear students, that is the end of this video. This video I have kept it short purposely because there are many important questions. And to if you want to learn the in-depth concepts, see, this is just the ultimate bridge series in which I have told you just the superficial things. Of course, this is not the detailed thing. So if you want to learn in detail, this on our maths 1 year program, and this is only and only available for rupees 9,999. No, dear students, this is only and only available for 999 if you enroll it right now. So just scan here. The offer is very limited. Of course, if you like scan it and find the price rupees 9,900, that means the offer has expired. The seats are full. The seats are limited as of now. We are filling, the seats are filling very fast. So scan this QR code, or the link is provided in the description box as well. So you will get this on only rupees 999. The classes are starting from May 5th. The batches are filling very, very, very fast. All right, so thank you, dear students. Thank you so much for joining. This is again available for only rupees 999, and you're going to get top IIT and NIT teachers. And it is powered by Sysya AI. Now, what is Sysya AI? In Sysya AI, you're getting all AI support, that is text to text dot solving. If you just type a text, you will get the answer. There's speech to text. Suppose if you don't want to write, you will just speak. Sysya AI, tell me the answer for this question. You explain the question. Find the area of sector. The angle is 30 degree, and tell me the answer. Of course, yes. Image to text. Suppose if you're that lazy as well, just click the image of the question, you will get the answer. You will never see this in any other feature, any other platform. You can check it. And in this price, 999, we are providing, and why we are providing, you may be thinking, this is just the beginning. This is just the inception of the session. That is why we are providing this. We just want to spread the word. And of course, we will need your help as well. If you found our classes useful, be it my class, Shrikesh sir class, or Kaushik sir class, or Satish sir class, or any other class, if you found it useful, make sure you spread the word. We need your help here, and dear students, that is the least which we can ask. All right, there are going to be 10,000 plus live session at 1,000 plus sessions, right? There's a 10,000 plus hours. All right. So thank you, dear students, for joining with me. Download the Sisya class app now if you haven't downloaded, and please like, share, and subscribe. All right. Thank you so much. I will be back with yet another video in this Ultimate Bridge series, and keep studying, stay safe, and I'll see you.